There we go. So yeah, we are Rafael and Anthony, and we want to talk about surviving the offline status. I was not there, but we went to the Progressive Web Dev Summit hosted by Google, and we found it really interesting. So we tried to dig. So yeah, let's go on.
Okay, so what are you going to talk about today? We're going to talk about progressive web apps. What are they all about? We're going to talk a bit about this new offline first approach. What kind of principles you have to keep in mind while working with it, and also a little bit about UX regarding UX first, and also talk about the current state and adoption status of these things on our browser manufacturers.
Yeah, so we're going to try to see how the future is going to look like, but also taking for nowadays what can you use already. And we are getting our hands dirty with a simple example. And we are going to explore mainly two technologies, service workers and IndexedDB. So, what's a progressive app?
Well, a progressive web app, as that huge tag says, is progressive, meaning that it works for every user, no matter what browser they're using.
Yeah, it's also responsive, so it can fit any size, any device.
Like we referred, it's connectivity independent, meaning it doesn't really matter a lot if you're offline or online at the moment.
Looks like an app, and the goal is that really feels and is performant as an app.
Yeah, stays permanently fresh. Meaning that the updates for it to be updated are extremely fast and on the fly.
It's designed also to be safe, so you don't want you want to prevent other people getting in your resources and injecting scripts into your app.
It is also discoverable, meaning that it is identifiable as an application, and that's mostly thanks to the W3C consortium, which we'll talk about a bit later. That was the current state and how it will evolve in the future.
It's re-engageable, so it provides nice APIs to engage the user and make it really feel like an app, send push notifications and synchronizing with the world when you are online again.
Yeah. Also installable, meaning that when you access the app the first time, it's going to install on your browser, and even if you turn on the tab, if you turn off the browser, if you turn off your computer, it's going to still be installed there to be used later when you access the website again.
And that's really nice because you can install it on your cell phone without having to go to any app store, and it's also linkable, so you can easily share it when you like something. So yeah, let's talk about also the benefits. What we got amazed is that you don't fail to the user. What we usually have as a web developers is a bit this. You don't have internet or you don't have connection, so big sad face is like, meh, I will have to wait until we are out of the tunnel.
It's also performant, especially because of the service workers we're going to talk a little bit further on. We can make a web application be faster than any web application was before. We can actually be on top and competing with native apps, or even faster than native apps, which is really interesting.
And yeah, we are working offline, so it's a better user experience. You can notify them. You are not offline, the usability or the things you can do are not fully, but you can still be productive.
Yeah, but the fact that you're offline but you can still give something to the user means better UX. Better UX means the user feels happier because things are better. It's going to increase your turnover percentage. It's also going to increase your brand recognition because your app is now better than the others. And you all know what that means, more monies.
So now you know how to sell it to the product owner.
Yeah.
Okay, so let's take a look to the state of the art. This talk is about our little experiment. We are preparing a bigger talk, but we thought let's share with the guys what we have so far. But it's also about the browser vendors, their experiments, what they are trying to release, and it's a bit the cutting edge.
Yeah. So if our talk isn't as awesome as Prashant's and David's talk, I'm sorry, we're still working on it. This is still not the complete version of the future, but it will improve and we'll share it when it's completely done, so to speak. Anyway, regarding the browser option, service workers isn't exactly the newest thing on the planet. Jake Archibald from Google has been talking about them for about 2 years now, but kind of like what David said about web components, it's still not super used. And even right now, on a W3C consortium, it's still considered as a working draft. The biggest browsers, being that Chrome and Firefox, have already implemented it pretty well. It's not 100% perfect, but it's also already pretty good. But of course, our IEs and Safaris are still lagging behind, and eventually they'll get there, but it's still experimental, so keep that in mind.
They promised to deliver, so they accepted that this is the way to go. That's important also to know. And regarding IndexedDB, it's a more mature technology. It's already implemented almost by everybody. The black sheep is the Opera King. So yeah, let's go further and let's talk about what are service workers.
So yeah, what are service workers? Service worker is a specific type of web worker, meaning it has its own thread. And it's a web worker that its job is to work on cache. So as most of you already know, app cache and cache manifest was already deprecated, and this is going to be the future of caching. But they're going to go way beyond caching. A service worker will be able to intercept network requests your browser makes, or your client makes, and actually respond with the cache. So that way the browser does not even have to talk to the server. Because the service worker is going to intercept, and let's say I want the file index.html. It's going to intercept that fetch, and it's going to give back the index.html it has already on cache. So that's one of the reasons why it's so fast. You don't even have to talk to the browser, to the server, sorry. It goes automatically. And not only it intercepts fetch, but also the push and async notifications to make it possible for it to be a complete progressive web app.
Yeah, it's also worth to say that there are a web worker, so they run on a separate thread. Here we can see a bit that they have a life cycle, of course, but we are going to go deeper or see it better working on the code. So yeah, maybe it's time to show a bit a hello world of service workers, but at the very minimum, or when you are on your computer and you say, it works, and your society is like, ah! And the developer tools, what we get to work with it, and the debugging, anything. So this is our basic setup. We have here a sad face because the network is down, the server cannot be reached. Here I have a terminal with it's really a simple node server that is gonna tell us every time you ask for a resource, it's gonna plot it out like index.html, index.html. Let's have it running. Clean this, and this is only just the browser terminal. So let's show you what's the goal, and this is our amazing application. It's a to-do list. We are really original. And what you can do is, well, you can say who you are and add a new to-do list, and when you have something that is done, you remove it, and oh, magic is done. As you can see here, we have some comments, and we detected already that your browser supports service workers, and we also say, okay, we are registering service worker. So we have a hello world prepared already. Let's see what happens if we stop the server. So this guy is killed, and we reload the page. Ta-da-dum!
Yeah, so this is our Hello World demonstration. It's not super interesting. Basically, it's the most basic service worker. What it does is that it installs itself on your browser, and then after that, it will intercept all calls and request, sorry, and it will return the same dump HTML file we created. We just created out of the blue so we can show that it doesn't have to be like something really simple. It has SVG, CSS, JavaScript, and some animations as a proof of our hello world that it actually has a lot of potential.
You can put anything there.
Yeah, but of course, this is not very interesting for your production websites of your billion-dollar company. So right now, we need to remove the service worker because it's kind of useless. So what we can do now, the good people at Chrome, they created this little page for us, Chrome Service Worker Internals. If right now you go on your browser and you visit this page, you're going to be able to see all the service workers that are already installed on your browser. And right now, because this is Chrome Canary and you use it for development, not to search for porn or anything else, we don't have Google, Google Service Worker and our own little service worker on our local hosts. We can use this little page here to inspect the code of your service worker, actually open a Chrome DevTools window to see the code automatically. We can stop it and register it. And register here means uninstall. So because we don't want it right now, we're going to stop it and register it, so goodbye.
So now your server is off and your service worker is also installed. If you go back to our amazing hello world and we reload, sad face again. So far, everybody with us? Yep. So let's change this a bit and let's switch it to our service worker, how we imagine or how we want it to work. And let's walk a bit in the life cycle of it. So we are going to start the server again, and we are going to reload the page. And well, you can see here all the resources that have been served is a list of all the images and libraries that we need to show this page. But you can also see here that we detected again that the browser supports service workers, and we are going to the first step. So in the index.html or somewhere, you have something like, okay, my browser supports service workers, awesome. Let's call the special method register, which is kind of install your service worker in the browser. And if this goes good, log it, and if not, say, okay, you don't support the service workers. And now starts the interesting stuff. The first thing a service worker does is getting registered, and registered in a specific scope. So here we are saying that our little service worker is going to be registered with the scope localhost port 8000 / that's the root. You could have one for the CSS, or you could have one for the JS, but you have to keep in mind that you cannot go up in your scope. So you could not go from the CSS, if your scope is /CSS, you could not access other resources or cache other resources. After this is clear for the browser, you proceed to install. Let's take a look to the service worker.js, and we are at the step install. Yeah. So yeah, when you're installing your service worker, this is the right moment that you should cache your things. So right here on our service worker file, we have a set of assets that we want to cache. This is every single file we have on our application, so it's not even that big. So what we're doing here is that we're making the event of install wait until our function that updates cache is finished. And what that function is going to do is actually extremely simple. Keep in mind, because this is all very recent, service workers already work with the premise that promises already exist. So ES6 is a sort of a common thing here, which is one of the reasons why it's still in a working draft on W3C. Anyway, what we do here is open caches. Caches is a reserved word which points to the cache storage object instance of your own particular service worker. So what we're doing here, we're opening caches with, this is a function we made that returns a string. So basically we call this cache a string something. In this case, we're going to call it our date, the current date and static and the version number. And after it's opened,
we have access to the cache of that specific name, and after that we can cache, add all the URLs to cache, which is just a simple array string we had on our file that I showed you just a little bit ago. And after this, we can go on to the next event of the server lifecycle, which is activate.
Yeah, so we come from install. So all the files that you define in the list are cached already successfully in your browser. And now we are going to proceed to activate the service worker. From this moment on, it's going to be able to intercept all the requests that the browser does and try to see if they match with the cache and respond with the cached version, or if not, go to the server and do all these clever things. But it's also a good moment to manage old cache that you can have. So we do so, and we see here that we don't have much. But now, if we clean this console, and also we clean the server, because this is the request that we did just now, and we try to reload our app, what's going to happen is that, first of all, the only resource requested to the server is the service worker. This is because anything that this web app requested to the server was in our cache, so it's all the message here. Is like fetch intersect. I have this resource, I give it to you, I don't ask to the server. So all these assets, all these JavaScript and CSS and basically and images that we have here have been in the cache, and we give it straight away to the browser. And why are we asking to the server the service worker? Because caching validation. We want to be sure that we are able to tell to the browser, you have an old service worker. So now if I reload this thing many times, it's going to ask only for the service worker. But if in our code I say, somewhere that we prepared specifically, that this is a new version, and I reload this page, what's going to do is reload from the cache, and I have all the assets, I serve them, but then see, and okay, I got the service worker that is new. So then I have to recache again all the assets that this service worker came with, and it's going to get installed again. Apart from that,
what if you would update an asset that is not the service? If you update the index, you will get the old index to the client.
Sorry, if I update my index...
instead of the service worker, you will update the index, so the service will be the same, so it won't search in the service.
Exactly. So if you have a cached resource that you updated in your server, but you didn't notify the service worker that is a new version, it's going to do that. So, good question.
You need to keep in mind that the service worker version, if you change one of your assets, should change. You can set like an automated task that could change the version name. What we've done so far is that our our cache name is the date of today dash static dash version number, which makes it a little bit easier to catch these little things. But it is something that you have to keep in mind, because it is possible to have new assets that your service worker is intercepting and delivering old assets.
A lot of deploying tools can create already manifest JSONs and things like that. So you could name your service worker with a timestamp and with a build version, so you would be sure that you renew it each time or per deploy to production. This is basic, simple caching validation mechanism.
So now that we've shown you how it works, we've talked a lot about intercepting calls, and this is where the fetch gets into. So whenever the browser is asking for an asset, you're doing a fetch. So what we're doing here, we're latching on the fetch event, and we're logging to see, okay, we got it. So in this case, if any of our caches matches what is requested by the event, then we're going to return it. So in this case, cache receipts, and the server didn't even need to work in this case. If not, we can do what is called preemptive caching or intelligent caching, which is we're going to get what you requested, and we're going to cache it ourselves, so in the future I can have everything that you've been asking for me, even if I didn't expect it in the beginning. Because the web apps are mutable and sometimes very unpredictable. And this is a little good thing to actually be ready for that kind of events.
Keep in mind that in this case you only want to cache assets, not data. If you're asking for the user ID or certain stuff, you probably don't want to keep it there in this kind of cache. Yeah, I think...
so yeah, that is basically like in a high level, most of the things regarding service workers. So keep in mind, the service worker lifecycle, installing, in between installing and activating, you cannot intercept anything, but you can already cache stuff. And after you're activating, you can already intercept stuff, and that's where things get interesting. So right now, you've seen that our web works offline, fortunately. Yesterday it didn't. And that was like the high-level view of service workers. You can, of course, later check this code because it's on GitHub and it's available for everyone to see.
Another last thing, every time you reload this page, you're going to see that inside the messages, there is still, because the service worker is requested, there is the event of registering this received service worker and installing it, but the browser is clever enough to see that the version is the same and don't break any part of the life cycle you are already in. So don't worry, but keep in mind that you will get an installation event every time you load the page.
Yeah. Also, something that we entirely forgot and was totally on the script is that it's not difficult to debug a service worker code. It's JavaScript. So what I gotta do is get here. Right now we got two service workers because one of them was removed but not unregistered. So they're still both very much live in a sense. But what you want to do, yeah, you want to get there, and then you want to just check the service worker, and that's it. And here you can do debugging, you can change your context. Even here, if you go on console, yeah, it works perfectly like a normal JavaScript file. It's super simple, and yeah, it doesn't hurt. And even if you come here on the console, you can actually change here your context. If you're on the window, or if you're on a specific web worker, service worker, which is pretty useful.
So let's try to move on.
Yeah.
Where do I have my presentation? Here.
Okay, so now we've been talking about service workers. It's time to step up to the next tech we're going to refer. This is IndexedDB. I don't know if most of you have heard about IndexedDB or not. It's actually not that new, but not a lot of people know it, which is a shame because a lot of people don't know that their browser actually has a database in it. SQL-ish like database. So in this little part, we're going to talk about what is IndexedDB, use cases dealing with the callbacks of programming with IndexedDB, because unlike service workers, IndexedDB has been on the market for more time, being a more mature technology, so it's not using promises like service workers. And of course, like any other database, you need to be careful about your data schema and indexing information for making queries faster.
Yeah, so you can provide the indexes you want. And of course, all the good operations are on the API. And we are also going to see a bit what are the developer tools and how you can inspect it or see it on your browser. Okay, that's for later. So let's go on.
Yeah, so basically, if you want to go, we have two different files because we have one file to create the IndexedDB and another file to be another layer of making a more generic CRUD API, getting any kind of IndexedDB. So it's just like, it's a more generic way of working it, but keep in mind it's not that complicated. We just complicated it to make it prettier and sexier, kind of.
So I don't know if I should say it, but what we store in the IndexedDB is all the nodes. So all this user information that was filled here and I want to have it offline is stored in the IndexedDB.
Yeah, they're all JSON objects, pretty simple. And actually, if you want to go on your browser right now, you can actually go here on Application, and here it is. Our IndexedDB, it's called To-Do List Store. It has this little object store, and you can actually see all the objects that are already in it right now. And here are available all the indexes, so you can actually do some quick searching here. And also, you can actually refresh your database or clean it, removing everything. Let's not do that right now, please. So, to create an IndexedDB, you need to access your window and open, and so you need to provide a name for IndexedDB, in our case just a to-do list store, and a version. That is actually useful because this allows you to not only create an IndexedDB instance, but you can also upgrade it, meaning that if by chance your app has changed the schema or anything or something like that, but you don't want to delete all your data because it's important for you, you can actually just upgrade it, which is really awesome. So here we're, because we're using callbacks, we're enveloping with promises just to make things a little bit cleaner. But basically we're making here the request of opening the database. If it fails, we're going to get sad and log that we're sad. If it opens, we're going to get happy. But now here's comes the tricky part. We got here unsuccess and unupgrade needed. What does this mean? Unsuccess will run only when the database is solely created. Unupgrade needed will run every time the database is upgraded or created from scratch. Meaning that now we've already done a few reloads, the database is already there, created, so it's only going to go on unsuccess. But if this was our first time opening the database, so we killed everything on the browser or installed a new browser, something like that, it would run on upgrade needed and not on success. Also, that would happen, like I said, if we upgrade it. So let's go for that. So when we create a database, we're going to get here the database reference from your events results. And of course, again, if it's an error, we're going to be sad. If not, we're going to create an object store. What is an object store? It's pretty much the analogous thing you have to a table on a SQL database. So you can have, your IndexedDB can have several object stores, like a database can have several tables. And on that object store, you're going to give it a name, and in this case it's the same name as the database, the to-do list store, and you're going to give it a primary key. So this is an attribute of your JSON objects that is considered a primary key on each object that is inserted. So we get our to-do store request, or our to-do store there, and we then add indexes. We just have an array of indexes here, and for each index you have to get it its name, so the index's name, but also the attribute it's going to point towards. And after that, also, if it's a unique or not. After that, something that I forgot to tell you, every single operation that you do on an object store is going to be enveloped in a transaction. On some of the API, the transaction is hidden within the native function that you're calling. If not, what you're going to do is what we're going to do here is using the onComplete. So that means that the transaction of doing this and then this is done. And after that, then we can finally start using our IndexedDB, which will be used more properly here.
So this is basically a layer well, what we are doing here is a bit wrapping all this callback hell API into promises. And you remember the object store that Rafa mentioned right now? Basically here what we have is a set of operation, list, get, delete, insert, modify, blah blah blah. And basically what we are doing is first getting this object store, and then we return a promise. We set up the object store with, we say, okay, we are going to perform a transaction, and we have to set the permissions. We can be a read-only operation or a read-write. Do we have? Yeah, here. And when this is ready, we are going to return a promise that is going to perform this operation in this case get. And when on error we are going to reject the promise, and on success we are going to resolve with what we actually got.
And actually, this little way of doing it is exactly the same thing for all the CRUD operations, because IndexedDB already gives you a proper API to do all these things. So yeah, it's just enveloping in a promise, and instead of calling get all, we're calling just get or insert or whatever you need. So this actually makes it possible for me to just get here, write something. Yeah.
Let's show the console.
Oh yeah, you're right. Yeah, I'm an idiot, sorry. Yeah, so we made it obvious that everything that comes from a service worker is written as yellow, and everything that comes from IndexedDB is written as blue. So here, every time you come here and you reload this, what's happening here is that after the IndexedDB is opened, you do a list to get all the JSON to populate the UI, which is pretty obvious. And after that, you can just do something here, blah blah, and my awesome user email, submit it, and voila! It just went through that function we just showed you, and boom, it's here. And now it's done. Goodbye. And that is basically how you use CRUD operations over an IndexedDB, which is very useful because it's going to be always stored on your browser.
This browser API is also available on a web worker. So you could separate all the logic in a specific thread for handling database storage.
Which, by the way, is what we're going to do in the future. Because right now our main UI thread is doing the database stuff, which is bad. It shouldn't be like that. And eventually we're going to change to a web worker, making sure that your UI thread is only used for handling UI, which should be the consistent practice.
And I think this is more or less, right?
Yeah, this is mostly it. So, nope, this direction. So, yeah. Well, thank you for your patience and listening to us. We hope you liked it. We were also idiots and we forgot to add our GitHub and tweet and etc. handle in the beginning of the presentation, but at least we remember this part. It's available here on this GitHub. And yeah, that's mostly it for me.
Any questions?
Don't be afraid.
If you update the version, but let's say it's only a really small update, it's possible to only reinstall those changed files?
I think that in the install process you have to reload everything.
Yeah, because it's a new service worker, meaning that the old one, it's going to be forgotten, so to speak. And you have to recache everything.
Could you run multiple service workers on a single page?
Yes.
And maybe solve that sort of issues?
Yeah. What's kind of a little bit what Anthony said a while ago was that you provide your scope when you're registering your service worker. And right now, by default, we're putting localhost anything is going to be on that service worker. But we can put localhost wiki and then localhost Twitter. And we can have several service workers handling different things. It really depends on how you want to build your app and your architecture.
You could have one for the fonts, one for the CSS, and one for the scripts, for instance.
Yeah.
Like the fonts and the fonts and the images don't change that often.
Yeah.
Also, it's important to measure that because it's designed to be secure. Here it works because it's localhost, but if you put it in production, it must be under HTTPS.
Yeah. Otherwise, it's not going to work at all. And that's very obvious because the service worker has a lot of power. It intercepts every fetch, async, and push network requests, which could be dangerous. So yeah, that's part of the specification. It has to be at all times under HTTPS. Yes. So you can start tapping.